So far we have seen the trigonometric functions sine, cosine, tan, cosec, sec and cot. These functions are not one on their defined domain and range set. Now the question is how we can find the inverse of these functions. As these functions are not one, they are definitely not invertible. The inverse of this trigonometric function doesn't exist. Now the second level question comes is that can we restrict the domain of these trigonometric functions to make it an invertible one? Let us see. Let us see by means of the example of the trigonometric function sine. So what is the sine function's domain and range? The function sine has domain are the set of all real numbers. And what is the range? Range is the closed interval -1 to +1. That means its domain is the entire real number set, entire real numbers, and the range, the values of sine are always in between -1 to +1, including -1 and +1. Now we are going to discuss that how we can restrict the domain so that we can make the function invertible. So if we draw the trigonometric functions sine, it looks like this. It is the positive direction of x-axis. This is the negative direction of x-axis. This is positive direction of y-axis. This is negative direction of y-axis. So let us take this one. It is let us take the x-axis measurement with the interval of pi/2. Then it is pi/2. Then it is pi. Then it is 3pi/2. Then it is 2 pi and so on. Here we see -pi/2 in the negative direction of x-axis. It is -pi. It is -3pi/2, and this is -2 pi and so on. Now let us quickly draw the graphical representation of the function sine. So here it is +1 in the positive direction of y-axis, and here it is -1 in the negative direction of y-axis. So how the function sine looks like in its graphical representation? Like this. Okay. Now we see the function sine is not 1 in the defined range, because we see, for example, the value 0. At 0, sine of 0 is 0. Again at pi, sine of pi is 0. So 0 and pi are two different elements in the domain set, but we see their images, that is sine 0 and sine pi, the images are same, because sine 0 is equal to sine pi equal to 0. But 0 and pi are different. So we see the function sine is not 1, as it is not 1, there is no question the function is invertible, right? Now the point is that can we restrict the entire domain of the function sine so that we can make this function sine invertible? The answer is yes, we can. Now if we make the function, let us draw it very properly. If we draw it properly, it looks like this one. It comes like this, and from here it will go like this. Okay, fine. So this is actually pi. My point is that here it is -pi/2. Let's write it in the top. -pi/2. So if we take -pi/2, sorry, I need to draw the diagram very clearly so that it will be clearly understandable. And here it is pi/2. the point is that if we restrict the domain of the function sine from minus pi by 2 to pi by 2, that means if we consider only this portion of the curve, of sine, then we can tell yes, the function sine is 1, 1. Why it is 1, 1? Because you take any value between minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, the values of sine are distinct, right? Just like this, they are distinct. And it is definitely on 2. That means between the value minus 1 and 1, you take any value, you will find one angle in the range minus pi by 2 to pi by 2. So we see, if we restrict the domain, from R to minus pi by 2 to pi by 2, that is a closed interval, that means including minus pi by 2 to and pi by 2, then we can make the function sine 1, 1 and onto both. That means it is invertible. So the conclusion of this discussion is that the function sine is invertible when the function sine has the domain set minus pi by 2 to pi by 2 closed interval and the range set minus 1 to 1. Alright, so as the function inverse of this function exists, so we can define it as sine inverse, right? Inverse of the function sine. So sine inverse, the function sine inverse has its domain. What is the domain of this function sine inverse and what is the range? Let's see. So domain of this function sine inverse should be the range of the function sine, right? So that means domain should be minus 1 to plus 1, the closed interval. And what will be the range? The range will be that the restricted domain of the function sine to make it invertible, that is minus pi by 2 to plus pi by 2. That means it is minus pi by 2 to pi by 2. Clear? So how we can define that? Let's write in different manner. Sine inverse of sine x is equal to x. Definite, right? Because we know the inverse of the same function is the value itself, right? That is f inverse of fx is equal to x. Again, f of f inverse x is equal to x. So the moment I write here sine inverse of sine x equal to x, that means when x belongs to what? Sine inverse of sine x equal to x when x belongs to minus pi by 2 to pi by 2. And sine of sine inverse x, that is also equal to x, but when x is belongs to minus 1 to plus 1. Alright. So what we see? We see that when we write y equal to sine x, where x belongs to minus pi by 2 to pi by 2 and y belongs to minus 1 to plus 1. Alright? This implies x equal to sine inverse of y, where y belongs to minus 1 to plus 1 and x belongs to minus pi by 2 to pi by 2. So inverse of this function we can write in this way, subject to this condition that x and y belongs to this particular set defined here. And we also see sine inverse of sine x equal to x when x belongs to minus pi by 2 to pi by 2, and sine of sine inverse x is equal to x when x belongs to minus 1 to plus 1 closed interval. Clear? Having said all this, I would like to mention one very important statement, is that sine inverse x and sin x inverse are not equal. These two has different meaning. Never mix them up. What is that? Sin inverse x and sin x inverse are two different things. What is sin x inverse? Sin x inverse is equal to 1 by sin x. And what is sin inverse x? It is the inverse of the function sine. And here it is the reciprocal of the function sine x inverse. Okay, these two are not same. Now, what do we see? We see that if we restrict the domain and range of the trigonometric functions sine, we can make the function invertible. In the similar manner, we can restrict the domain of the function cosine, tan, sec, cosec, cot to make these functions invertible. So, what are the restricted domain or to make these functions invertible, we will say in our next session. Thank you.